Hi everybody, I want to talk about Descartes' rule of signs theorem. The purpose of it is that it can allow us to determine the possible and location of our real zeros. And so what it relies upon is you count the sign changes in your polynomial by looking at the coefficients. So for instance, these are both positive, so that's not a sign change. But then you have a positive 2 and a negative 5, and that changes signs. So when you have that sign change, you count those, and then that determines the possible number of zeros, or else that number less than an even integer. So what's happening is the number of positive real zeros of f either equals the number of variations of the sign of the non-zero coefficients, meaning just count the when it changes from positive to negative or from negative to positive. And then once you count the number of sign changes, that's going to be the number of possible real zeros, and then else equals that number less than an even integer. So if you ended up with 4 sign changes, you would also have 4 positive real zeros, 2 positive real zeros, or 0 positive real zeros. To find the number of negative real zeros of f, that's going to either equal the number of variations of the sign of the non-zero coefficients of f of negative x, or else equals that number less than an even integer. So you're going to be still counting the sign changes, but it's for f of negative x. And so the negative and negative, so you can keep track of it that way. Alright, so let's look at part A. Let's write it again. We have f of x equals x cubed plus 2x squared minus 5x minus 6. And so what's happening is we want to count the number of sign changes, and it starts off positive, so that does not change signs, but when it goes positive to negative, that does count as a sign change. Negative does not count as a sign change. So we have one sign change. So then that means we have one positive real zero. Alright, so then to find the negative real zeros, we need to find f of negative x, which is negative x to the third plus 2 times negative x squared minus 5 times negative x minus 6. Alright, this will be negative x cubed plus 2x squared plus 5x minus 6. And when we count the sign changes, it's going to be 1 and 2. So this means you have 2 sign changes, which means we'll have 2 negative real zeros, or 0 negative real zeros. So you're going to get 2 minus 2 is the 0. Alright. So let's look at part B. Let's go ahead and count the sign changes just from the function here. It's changing once, twice, and 3 times. So that's 3 sign changes. So this means that you can have 3 positive real zeros or 1 positive real zero. Again, because it's less than an even integer, 2 is an even integer, 3 minus 2 is going to be your 1. When we find f of negative x, so the negative x to an odd number is negative, and then even it's going to stay the same. Odd is going to be minus, plus 2x squared, plus x, minus 3. And when we count the sign changes, 1 and 2. This means that there's 2 sign changes, and that means that there's 2 negative real zeros or 0 negative real zeros. And so the reason why this is, you'll see that this is helpful, is that when we cover the rational zeros theorem, you're listing potential rational zeros of a polynomial function. So those can be positive or negative. And when you apply the Descartes rule of sign, you can be like, oh, well, I have 3 positive real zeros. It's going to make more sense to check a little bit more positive real zeros than you would negative. And just as a reminder that this is a degree 7, so we should expect at most 7 zeros. Alright, so I hope you found this helpful, and I'll see you in another video.